Good day, everyone. Today, we will learn about determining and applying appropriate metric units. Every day, we measure different things. We measure the distance we travel, the amount of water we drink, the mass of the food we buy, and even the size of tiny organisms that cannot be seen by the naked eye. Choosing the correct unit of measurement is important because it allows us to communicate measurements accurately and avoid confusion. By the end of today's lesson, you'll be able to identify the appropriate metric unit for different real-life situations. Let's begin with a simple activity. Suppose I ask you to measure these objects: a cell phone, a sack of rice, a medicine tablet, a bottle of water, a basketball court, a swimming pool, and a virus. Would you use the same unit for all of them? Of course not. A virus is extremely small, while a swimming pool is very large. A medicine tablet is measured differently from a basketball court. This tells us that the unit we choose depends on what is being measured and how large or small it is. At the end of today's lesson, you should be able to identify different measurement quantities, determine the appropriate metric unit for various contexts, apply metric units in real-life situations, and justify your choice of metric unit. As we go through the lesson, think about how these skills can help you in your daily life and in your future profession. Before we proceed, let's watch a short video about the metric system. As you watch, pay attention to what the metric system is, why many countries use it, and how different metric units are related. After watching, we'll discuss the important ideas together. The metric system is a decimal-based system of measurement used by most countries around the world. It is called decimal-based because it is based on multiples and submultiples of 10, making calculations and conversions much easier. Some common base units include meter for length, gram for mass, and liter for volume or capacity. The metric system is widely used because it is simple, accurate, internationally accepted, and very useful in science, engineering, medicine, and technology. Before choosing a unit, we must first identify what we are measuring. Different quantities require different units. For example, length measures distance. Mass measures the amount of matter an object contains. Capacity tells us how much liquid a container can hold. Area measures the size of a surface. Volume measures the space occupied by a three-dimensional object. Temperature tells us how hot or cold something is. Finally, scientific size refers to extremely small objects such as bacteria, viruses, and DNA. The first question we should always ask is, what quantity am I measuring? Only then can we choose the most appropriate unit. Now let's match each quantity with its common metric units. For length, we use millimeter, centimeter, meter, and kilometer. For mass, we use milligram, gram, kilogram, and ton. For capacity, we commonly use milliliter, liter, and kiloliter. For area, we use square centimeter, square meter, hectare, and square kilometer. For volume, we use cubic centimeter and cubic meter. Temperature is commonly measured in degrees Celsius. For scientific measurements involving extremely small objects, we use micrometer and nanometer. Notice that every quantity has its own set of units. Choosing the correct one depends on the size of the object or quantity being measured. You may notice that many metric units have prefixes such as kilo, centi, milli, micro, and nano. These prefixes tell us how much larger or smaller a unit is compared with its base unit. For example, kilo means 1,000 times the base unit. Centi means 1/100th. Milli means 1,000th. Micro means 1/1,000,000th. And nano means 1/1,000,000,000th. Understanding these prefixes helps us appreciate why some units are appropriate for very large objects while others are suitable for extremely small measurements. Let's apply what we've learned. A bridge is best measured in meters because its length is too large for centimeters but too small for kilometers. The distance between Manila and Batangas is measured in kilometers because it covers a long distance. The thickness of a coin is measured in millimeters because it is very small. Notice that although all three involve length, they require different units depending on size. Now let's look at mass. A medicine tablet is measured in milligrams because it has a very small mass. An apple is measured in grams. A sack of rice is measured in kilograms. A cargo truck is measured in tons because it is extremely heavy. Again, the quantity remains the same in mass, but the unit changes depending on how heavy the object is. Eye drops contain only a small amount of liquid, so we use milliliters. A bottle of juice is commonly measured in liters. A water tank occupies a large amount of space, so we measure its volume in cubic meters. The same is true for a swimming pool. Remember that capacity usually refers to the amount of liquid a container can hold, while volume refers to the space occupied by a three-dimensional object. For area, a notebook cover is measured in square centimeters. A basketball court is measured in square meters. A rice field is commonly measured in hectares. The land area of a province is measured in square kilometers. Now let's look at scientific measurements. A virus is measured in nanometers. The width of a human hair is measured in micrometers. DNA is also measured in nanometers because it is extremely small. These examples show that very tiny objects require specialized metric units. Let's review what we have learned today. A measurement quantity tells us what is being measured, such as length, mass, capacity, area, volume, temperature, and scientific size. Each measurement quantity has its own appropriate metric units. For length, we use units such as millimeter, centimeter, meter, and kilometer. For mass, we use milligram, gram, kilogram, and ton. For capacity, we use milliliter, liter, and kiloliter. For area, we use square centimeter, square meter, hectare, and square kilometer. For volume, we use cubic centimeter and cubic meter. For temperature, we commonly use degrees Celsius. For scientific measurements, we use micrometer and nanometer. Finally, remember that the appropriate metric unit depends on what is being measured and the size of the object or quantity. Before we end today's lesson, take a moment to reflect on this question. Why is choosing the correct unit of measurement important in everyday life, science, engineering, and medicine? As you go about your daily activities, observe the objects around you and think about the metric unit that is most appropriate for measuring each one. Remember, selecting the correct unit is the first step toward making accurate and meaningful measurements. Thank you, everyone, for your active participation today. We'll continue our next lesson by learning how to convert measurements within and between different measurement systems.